Hi guys, welcome to Secure Chain Fridays, a secure supply chain series. In the last few weeks, we talked about what is a software supply chain is and what is SLSN framework, also called as SALSA framework, and then we talked about how important provenance is. Now, today we'll talk about transparency logs, which is another way to check if your containers are signed. And also, it is another, what do you say, evidence. So, let's talk about the agenda. First of all, we'll talk about the importance of metadata and the significance of signed metadata because by metadata you can check for recovery and you can check where your container was, where your software artifacts were. And then we will talk about different ways to store signed metadata, and then we'll jump onto the topic, that's transparency logs. That is another hand of the salsa framework. Then we'll talk about a very powerful tool, that is Rekor, which helps us to generate transparency logs, and we'll talk about how it works, and we'll see how it look like in real time. So just for your information, this video is not an installation video. We will just talk about how Rekor functions and what are transparency logs and what are its importance in a salsa framework or in a secured supply chain. So if you want to look for installation, you can go to the official website of Secure Record, and it is a very simple process. It's a single command. You can run it on Brew or anything else, or just like we did for Sift, Gripe. And also, if you want to check out about provenance, you can check out my last video that is 2 weeks ago. So let's get started. So today's agenda, that's safeguarding metadata with Rekor. So first of all, we'll talk about the importance of metadata. So in a software supply chain, metadata refers to additional information which describes context about various elements within the software development and delivery process, also referred to as the build definition. Um, we talked about in the last video what a build definition, what are its components. And in this, we'll talk about some layman terms such as the version information, dependencies, build processes such as build numbers, timestamps, and the environment. So when we talk about Rekor, timestamp is a very crucial element, and it is always highlighted into the logs which it generates. So yes, we're talking about metadata. So this can include version information, of course, because it changes for every release, and it is very crucial to go back or to trace back. And you can say that it has the it has the context about different releases, dependencies, including compatibility requirements as well, and build information. So also you can include other information like authorship, licenses, checksums, and quality assurance. So if you check about, if you see the process, it will always have your provenance version, etc., and will have the hashes by which the log was created. We'll check it out at the end of the video. And this is crucial for tracking, managing, and securing software components as they move through different stages of the supply chain. Now, this is a comparison between a traditional supply chain and a software supply chain. So, uh, it is actually very hard to see or visualize it when it comes to software because it happens in nanoseconds. But if you compare it with a traditional supply chain, you see the logistics supply chain. Right here, let's talk about a food getting processed. Now, this is a gear, but we'll talk about food. That is the raw material. So that raw material gets processed into the factory and then delivered to the shopkeeper and to the consumer. Now, in this process, we have different quality checks and everything. So let's compare about how you can, how these metadata is incorporated into this traditional supply chain. So in the first step, where raw material is delivered to the factory, we will have the information of such like what was the raw material. If it's sugar, if it is going to a sugar mill, it will be a sugar cane. And then it will be the quality of the sugar cane. Was it organic or what, like that. Then at the factory, how it was processed is another addition to the metadata. Was it clean, and how there are different author different boards to check it. In India it's FSSAI, so like that. Later on we have information like quality control certificates or inspection reports which accompanies the product before it gets shipped. Also, we must add supplier information and their location at this stage. Mainly, it is given in the logos, so it is direct, and what the location where they processed it. Then we have the logistics stage that holds the shipping manifestations. And when this gets delivered, the consumer checks metadata such as manufacturing dates, expiration dates, etc. So these are all the metadata in a traditional supply chain, and these are all incorporated in at the back of the packaging, or it is compressed into a barcode. It is a unique identifier. Just like that, if now you can visualize this in a software supply chain, you will understand how it is incorporated into a software supply chain to check its integrity at different points. In the SLSP video, we checked how the integrity of software supply chain is compromised at different points. So, if you refer to that, you'll understand at what point we can add these unique identifiers. Similarly, we have the essentials such as if you check into this, these are the source dependencies. Then we'll add into the build information and the networks, the releases, and the deployed systems. So these are the metadata. It can differ onto the process of the application, how it is processed. So it will differ like that, just like it will differ for traditional supply chain. So this was just a mere comparison to give you the visualization of how things differ when the process is differing and the metadata differs, and how important is the metadata or the metadata annotation. If there's a packaging where you cannot see expiry date, manufacturing date, you wouldn't purchase it at the first place. So just like that, metadata is important for a software supply chain as well. Now, significance of signed metadata. Now, it is important that you know from where the metadata is coming, right? So signed metadata provides a mechanism to detect any unauthorized alteration or tampering of the metadata throughout the supply chain, which means tamper resistance. So it gives you the check that yes, while your container was moving throughout the software supply chain, it was not tampered with, or your application or your code was not tampered with. That is the what do you say? That is the assurance that the process gives you. If there's a platform or anything that implements frameworks like Salsa, so they give you the assurance that yes, your code would never be tampered with. Secondly, signed metadata provides a means to verify the origin of the information. Of course, that's how we check that it is not tampered with. That is our first priority. And by signing metadata, the software supply chain can establish a secure and reliable chain of custody for software components. Now, this keeps the integrity of the software supply chain as well. So when we talk about compromised supply chain, it gets at the first level as well. When a bad code is given into the or processed into the supply chain, that's the first point where the supply chain is compromised. And later on, there are different levels and different gaps that signed metadata bridges. So when signed metadata is stored in a tamper-resistant ledger, it creates an immutable record of changes and events in the software supply chain. So these were some of the major highlights, or what you can say. If you want it in a nutshell, of course, tamper resistance and origin verification. Then there's immutable ledger and supply chain integrity. So these were the few basic significance of signed metadata. Now, how you can store signed metadata. So these are some of the some of the different ways you can store signed metadata with. Today we will be talking about transparency log, but let's walk through these as well, because these are also some of the very convenient ways. So first of all, distributed version control system. So platforms like Git with commit signing provide a way to store signed metadata for source code configurations and other textual data. So when do we use it? We use it when Git report, when you have to track versions and changes in code at every nanosecond, and you can also check for configuration files and other text-based artifacts. I would like to highlight text-based artifacts are like these are the major ones that if you want to track these ones, you use distributed version control system or basically Git that is in action most of the time. And here commits can be signed for integrity verification. Second is immutable object storage. So immutable object storage or cloud object storage services like Amazon S3, Google Cloud Storage, or Azure Blob Storage provide immutable storage capabilities. Objects can be versioned and configured for read-only access. And so this one specifically gives you immutable ledger, right? So as we checked of the significance, this one is the most basic one, and you store use it when you have to store signed metadata as files or objects in a immutable storage system to prevent unauthorized modifications. Now then we have content addressable storage or like IPFS, which is the short form for interplanetary file system. So the content addressable storage system like the IPFS allow you to address content by its hash, ensuring data integrity. Now these all these three, when you use it, it gives you three different significance of signed metadata in at three different places. So it is better that we use one single tool. So such as transparency logs, which give you immutable ledger verification system, which gives you the assurance that your supply chain integrity is not tampered with, and also gives you hashes, the security of hashes in SHA-56 format. So that's why we use transparency logs. Not to forget, you can also use database with digital signatures, the traditional databases can be used to store signed metadata along with digital signatures. So it's like key value system, not particularly key value system, but like you can add it the indexes, and just like you store files and add their indexes, just like that you can also use databases. Now we will talk about transparency logs. So um, in layman terms, transparency logs are like public records or journals that store information about events or actions in a way that anyone can see and verify. So when you file an RTI or when like now this process is very transparent. So you not particularly RTI, but if you file something and you want to see your details or anything, if you want to see a tracking record or anything, you can go to the website and check. Just like that, these are public records or journals. So they're designed to provide openness and accountability. So the consumer, which we talked about, that the consumer awareness is just as important as implementing the securities. So if the consumer is aware and they checks out that yeah, this particular platform or this particular container was not tampered with or was signed with provenance, they or not signed with provenance, both ways, they can keep the DevOps people or the process platform engineers accountable for that. So More simplifying it, it is like a logbook where important events are written down and made available to the public, just like that. That's that's the gist. You can have a window to check the history of certain activities. So it's simple. So one specific type of transparency log is used in software supply chain security. This log, often associated with the projects like Rekor, the one that Rekor provides, stores cryptographic proofs related to software artifacts like container images. This helps ensure the software you're using has not been altered or compromised during its lifecycle, providing transparency and trust in the software supply chain. Now, how it works. So, the record, so first of all, let's not talk about how it looks. Let's talk about transparency logs. We talked about it. So these are some of the features of transparency logs. First of all, append only nature. So these transparency logs, why they are very why they are used popularly, because they cannot be changed. Once you have added something to it, they can only be appended, and they are not mutable per se. And by the records or by the histories, you can detect anomalies, of course, because it shows you how you used how secure your supply chain was and how your application was processed. Then there's a blockchain and distributed ledger technology. So here, blockchain and distributed ledger technology refers to Merkle tree. So blockchain popularly use Merkle tree algorithm. We'll talk about it in the next slide, and we'll see how record works. So in a gist, this algorithm helps create like the hashes and appends them together to create a root hash. Then we have cryptographic hashing and signing, of course, because it is necessary to encrypt the data. Then there's public accessibility, just like we talked about it, how public can see this. It is open like a logbook and keep you accountable for that. Then, of course, software supply chain security, that is the byproduct, and the tool record that we'll be talking about. Yes, the certificate transparency. So these hashes, these metadata annotation, record that yes, your container was signed, and it stores it with a timestamp. So let's see. Yes. So talking about the tool, that's Rekor. So Rekor is associated with CNCF and is designed to address the challenges of software supply chain security. It utilizes a transparency law to store cryptographic proofs, yes. And the primary purpose of Rekor is to provide a verifiable and transparent history of software artifacts, just like the logbook we talked about. Then let's see how it works. So this is a diagram of a Merkle tree. It is an algorithm. So let's imagine that you have a lot of entries, right? You have to enter a lot of names, and then you have to refer to them. You have thousands of entries. Here you can see there are only four. There are four, then two, and three. But in a container image, or when the data is processed in a supply chain, the entries are beyond 1,000. So how it gets, or how it refers, or how it indexes to a single point where for a single release. So it utilizes Merkle tree algorithm, where a hash is generated for each entry, and these hashes in even numbers are attached, and then another hash is created by appending these ones, not to say append, but to get processed, and then all these at the end create a root hash. So let's say these are even numbers, right? But if you have odd numbers, the end one will be appended twice, and then you will, of course, you will have even number ones, and then they're divided and divided until there is one root hash which it can refer to. So let's see it in real time. Yes. So in here, I have created this log from a signed, what do you say, from a signed image. So this is what it actually looks like, right? I have formatted it for your convenience. So this is the body, but let's not talk about it. Yes, this is what we need. Yeah, here you can see these are different hashes, right? These are single hashes, and then they're processed to create this particular root hash. Now, it also gives you the tree size, and this is for a single image for a single application. But if you have microservices, you have a lot of infrastructure, you you cannot store every one of them or every single one. So you use the Merkle tree, and it's super fast and super easy to use. And right here you can see the log ID. It would refer to the image you used, and it will also give you this particular link. When you generate a image with sign and you receive the information, you always get this link. This is the log index to which you can refer, and this is how it shows that your particular image is signed. So here you can see the signed entry stamp. Just like I said, timestamp is particularly a crucial step when Rekor works. It shows that at particular this time it is encrypted. The container was signed. So this particular as the on the contrary, it's this particular information is mutable. All this is immutable. You cannot tamper with it, but this particular information is mutable. So why you cannot do it? You cannot add something to it. But Rekor, when it works, it what it does for every release, for it mutates this one, like it adds into this one, and so it creates a signed timestamp every time. So this was how the log entries look in real time. I know it can be like it's not in context, but it is easier to understand it this way. Now let's see how transparency logs are integrated into the supply chain when you use Rekor. Yes. So this is the process of a supply chain, right? So these are the developers, and when they request a certificate, these are like different ways. The you can see that this process goes both ways, and in the middle you have the record transparency logs, which records after the signed certificate, or not to refer to it as signed certificate, but as provenance according to the SALSA framework. You can see that these transparency logs are indexed. Like the entry has been made when a certificate authority publishes a signed certificate. So it then there's end user. It checks the signature in the log. Where does it go? It goes to the index or the link that was created while creating the signed certificate, and it see the published evidence. Now there's this publish signed artifact. It can a signed artifact such as like if you don't have a full application or microservices or something like that, you have a single signed artifact, and that you can also download that artifact. That is another process. Just like we talked about how you can use databases, etc. Then there's also this process where you check that a party is trusted. How do you check it? You check it by seeing the transparency logs. So these are different ways where the transparency logs or the record works, right? So this is a whole process, and we forget how many times, like how these single entities, you say, these publishing of certificates and processing this whole through a secure supply chain is a huge process. It looks simple in this diagram, but it is a huge process. So, to save you from that, Initialize has come up with a unified DevSecOps platform, which from which you can skip the hassle, and it gives you SLSA level 2 security in its latest release, and uses Rekor to create or to index their signed certificates, or the provenance, etc. So if you wish to access initialize.ai, you can scan this QR. Also, you can visit our website, initialize.ai, and you can get an early access to our platform. Now, this was majorly about metadata and safeguarding it with Rekor. So now, next week we'll talk about observability, of course, and because it is also another part of a secure environment. And if you wish to, if you want me to create some content or some technology, you can add it into the comments, or you can reach out to me um, on my LinkedIn. So that was majorly it, and thank you for joining as always. You can, if you like the content, you can always subscribe and like our subscribe to our channel and follow us on LinkedIn as well. And for our latest update, you can connect with us on Discord. So thank you for joining, and I'll see you next Friday.